Namaste everyone, it's me Shailendra. Welcome you to online Monastic classes. Today we will discuss about the first chapter of Trigonometry of class 10, that is multiple angles and sub-multiple angles. Let's start today's class. First chapter of trigonometry in class 10 is multiple and sub-multiple angles. First of all, we have to know what is multiple angles. If AB any angle, then 2A, 3A, 4A, etc. are called multiple angles of angle A. Multiple of A is 2A, 3A, 4A. These are the multiple angles of A. Same way, if AB any angle, then when we say sub-multiple, it will mean fraction, that is not the whole part, that is 1 by 2, A by 2, A by 3, A by 4. These are called sub-multiple angles. Angles of angle A. So when A is the natural number, integers, then it is multiple angles. When it is in fraction, then it is sub-multiple angles. We have to know first how can we know the formula of this exercise. What's the way we have to remember the formula and how we can prove this formula. First of all, we have to use the formula of compound angle which we have learned in class 9. We have learned the formula of sine of A plus B. It is sine of A into cos of B plus cos of A into sine of B. That's the formula of compound angle which we have already completed in class 9. In class 10 we have to learn the first formula, that is sine of 2A, and the first formula of this is 2 times sine of A cos of A. How can we prove this? If in exam it is said to prove this condition, we have to use the formula of above, that is sine of A plus B. We can write 2A as A plus A. Now we can apply this formula. Change it where there is B, now it can be. So we can change this with A. So we can write sine of A into cos of A plus cos of A into sine of A. That is 2 times sine A cos A. That's the root. So we have the first formula Sine of 2a is 2 sine a cos a. Next, same formula, sine of 2a. Another formula is 2 tan a by 1 plus tan a square. To prove this formula, first of all, we have to prove up to this. We must have to use now formula 2 we have sine 2a formula 2 tan a by 1 plus tan square a. For this up to this nothing will be changed and we have to write 1 in the denominator. Any number divided by 1, result will be not changed. Now in place of 1, we can write cos square a plus sine square a. Because you know the formula sine square a plus cos square a is 1. We want the result here in 10. Here it is tan square. If we divide here by cos square a, then denominator will get 1 plus tan square a. For this, dividing numerator and denominator by cos square a, we get 2 sine of a into cos of a divided by cos square of a, cos square of a by cos square of a plus sine square a divided by cos square a. Then simplifying it, we got the final result what we want, 2 times tan a by 1 plus tan square a. That's the proof completed. Here we have learned how to put these in first. Then the process we have to remember, we have to put the 1 in place of 1, we can use cos square a plus sine square a. Then we have to divide it with cos square a. Then we have the third formula of sine, that is sine of 2a equals 2 times cot a by 1 plus cot square. For this, up to that, nothing will be changed. Only the change will be, we have to divide numerator and denominator by sine square a. Here in place of 1, we can write sine square a plus cos square a. Either you write cos square a plus sine square a plus cos square a, it doesn't differ. Both are same. Now dividing numerator and denominator by sine square a, we get 2 sine a cos a by sine square a, again in denominator sine square a divided by sine square cos square a divided by sine square a. That means 2 times, if we simplify, it can 2 times cot a by 1 plus cot square a, that is RHS. So what we got? We have now 3 formulas of sine of 2a. First formula, sine of 2a came 2 times sine a cos a. Second one came 2 times tan a by 1 plus tan square a. Then third one came 2 2 times cot A by 1 plus cot A square. When we have to convert this formula, these are the formula of multiple angles. To convert this into submultiple, what we have to remember, now in place of 2A, 2A is substituted by value A. Then wherever there is A, we must have to substitute it with by A by 2. So the formula became where there is 2A, we have to write A, and where there is A, we have to write A by 2. Again, then we have second formula 2 tan A by 1 plus tan square. Same changes we have to write where there is A. We can write A by 2, so it came 2 tan A by 2 divided by 1 plus tan square A by 2. We have the third formula here. Now same changes we have to do. 2 cot A by 2, 1 plus cot square A by 2. Now, how can we prove this formula? The same as what we have done earlier. Here is sine of A, but we want the result in A by 2. So, in place of A, now we can write A by 2 plus A by 2. Now, use the formula of compound angle. Sine A by 2 into cos A by 2 plus cos A by 2 into sine A by 2. It came 2 sine A by 2 into cos A by 2. First one is proved. When we have to prove this one, you have learned in earlier formula how we have proved it. In here in denominator we have written 1, but here is sine A by 2 cos A by 2. So what are the changes we have to do? What are the changes we have to do? In place of 1 now, we have to write cos square A by 2 plus sine square A by 2. Earlier we have written cos square A plus sine square A, but now we have written cos square A by 2 plus sine square A by 2. Then we have to divide in numerator and denominator by cos square A by 2. We get 2 sine A by 2 cos A by 2 divided by cos square A by 2 cos square A by 2 by cos square A by 2 plus sine square A by 2 divided by cos square A by 2. Do the simplify. You got the final result 2 tan A by 2 by 1 plus tan square A by 2. Same way, here only the changes will be dividing it with sine square A by 2. You will get the third result. In this way, we have completed the multiple and submultiple formula of sine 2A and sine A. And if we remember the multiple formula, we can easily remember the submultiple formula also. Now move further. Coming to the second formula, we have in compound angle we have learned cos of A plus B. It is cos A cos B minus sine A sine B. Now we have to do cos of 2A equal cos square A minus sine square A. To prove this, again same thing will be applied. We can use, in place of 2a, we can write a plus a, and we have to use the formula of cos of a plus b, that is cos a into cos b, but here is a, so cos a into cos a minus sine a into sine a, that is cos a squared a minus sine squared a. That's our first formula. Now coming to the second one, 1 minus 2 sine squared. Here you want the result in sine squared. You have learned in a square formula in class 9, cos squared a formula is 1 minus sine squared a. Now do the simplify. That's your result, 1 minus 2 sine squared a. We have the third formula, that is 2 cos squared a minus 1. Up to this we don't have to make any changes. Now we want the result in cos squared, so we have to convert sine squared into cos, and you know the formula, 1 minus cos squared a minus 1 minus minus plus cos squared a, that is 2 cos squared a minus 1. Then the fourth formula for this is 1 minus tan squared a by 1 plus tan squared a. You know how to convert it into tan. In earlier, in sine 2a formula we have learned, we will start to write in denominator 1. Then in place of 1, we can write cos squared a plus sine squared a. To convert into tan, we have to divide numerator and denominator by cos squared a, and to convert it into cot, we have to divide it with sine squared a. Dividing numerator and denominator by cos squared a, we get, that is cos squared a by cos squared a minus sine squared a by cos squared a, again in denominator cos squared a by cos squared a plus sine squared a by cos squared a. Solve this. That's the result we want, 1 minus tan squared a by 1 plus tan squared a. And finally, we have the fifth formula, that is cot squared a minus 1 by cot squared a plus 1. Now you have learned how to prove this. Here, divide numerator and denominator with sine squared a, you will get the final formula. And now what we have learned, we have learned 5 formulas of cos 2a. We have learned the first formula, cos squared a minus sine squared a. Second one, 1 minus 2 sine squared a. Third one, 2 cos squared a minus 1. Fourth one, 1 minus tan squared a by 1 plus tan squared a. And fifth one, cot squared a minus 1 by cot squared a plus 1. If we have to convert the same formula in submultiple, earlier we have learned in place of 2a we have to write a, and where there is a we have to write a by 2. So submultiple formula of this would be cos squared a by 2 minus sine squared a by 2. Second one will be 1 minus 2 sine squared a by 2. Third one is 2 cos squared a by 2 minus 1. Fourth one is 1 minus tan squared a by 2, 1 plus tan squared a by Fifth one is cot square a by 2 minus 1 by cot square a by 2 plus 1. And when we have to prove this, same as earlier, we have in place of cos a, cos of a by 2 plus a by 2, then writing the formula of compound angle, then solving it to get these things. Now we have the third formula of this exercise, that is tan of 2a to tan a by 1 minus tan square a. When we go through proof, in place of 2a we can again write same as a plus a, tan a plus tan a by 1 minus tan a into tan a. To the sum, to the simplification, it came 1 minus tan square a. Only one formula we have for tan 2a, and if we write the sum multiple formula of this, tan a to tan a by 2 by 1 minus tan square a by 2. That's the multiple and submultiple formula, tan 2a formula and tan a formula. Next formula we have cot 2a. We have formula cot square a minus 1 by 2 cot a. Exactly the same thing we will do what we have done in earlier formulas. In place of 2a cot a plus a, we have formula of cot a plus b cot a into cot b. But now we have cot a minus 1 by cot a plus cot a. That is cot square a minus 1 by 2 cot a. And its submultiple formula is cot a equal cot square a by 2 minus 1 by 2 times cot a by 2. Now we have few formulas which we have already proved, but simplifying these formula we will form few new formulas, that is formula number 5. 1 plus cos 2a equal to cos square a. That's one of the most important formula we will use from both sides. When we say what's the formula of 2 cos square a, that is 1 plus cos 2a. What's the formula of 1 plus cos 2a, 2 cos square a. If we have to prove this, we have learned the formula of cos 2a to cos square a minus 1. Do the simplification, that's it. And some multiple formula of this, 1 plus cos a is equal to 2 cos square a by 2. 1 minus cos 2a, 2 sine square a. Again, we can use the formula of cos 2a. Cos 2a formula 1 minus 2 sine square a, 1 minus 1 plus 2 sine square a, 1 cancel, that is 2 sine square a. And some multiple formula of this will be 1 minus cos a is equal to 2 sine square a by 2. Few more formulas which we will simplify, then we will get as in 7 sine a plus cos a whole square is 1 plus sine 2a. We can directly use this formula, or instead of that, when we are solving the question, we have to prove the question, we can do the few steps same as this proof is completed. sine A plus cos A whole square. That's the formula of A plus B whole square. We will prefer to write A square plus B square plus 2AB. You know that sine square plus cos square A is 1 and 2 sine A cos A is sine 2A. And its submultiple formula will be given sine of A by 2 plus cos of A by 2 whole square is 1 plus sine B. In same, sine of A minus cos of A whole square is 1 minus sine 2A. And in this formula, we don't have to do anything exactly the same. In place of plus, here will be minus, then you will prove this. And its submultiple formula will be sine of A by 2 minus cos of A by 2 whole square is 1 minus sine A. Tan squared A. Well, 1 plus cos 1 minus cos 2A by 1 plus cos 2A. If we take the RHS here, we have learned the formula. 1 minus cos 2A formula is 2 sine square A, and 1 plus cos 2A formula is 2 cos square A, that is tan square A. Same way, its submultiple formula will be tan square A by 2 equal 1 minus cos A by 1 plus cos A. These are the formula which we got after simplifying the earlier formula which we have completed. Like one of the formula we have tan A equal 1 minus cos 2A by sine 2A. RHS 1 minus cos 2A by sine 2A. And you put the value 1 minus cos 2A, 2 sine square A, sine 2A, 2 sine cos A. Do the simplification, these two cancel, it came sine A by cos A, that is tan A. Same way, the submultiple will be tan of A by 2 equal 1 minus cos A by sine A. These are the formula related with 2A and A by 2. Now we have few formulas with 3A. We have the first formula, sine of 3A, it is 3 sine A minus 4 sine cube A. What we have done in earlier, same thing we will do. In place of, here it is 3A, in place of 3A now we can write 2A plus A, because now we have 2A formula known to us, and we can write sine A into cos A plus cos A into sine B. We have sine 2A formula. In sine and cos only one formula. We have many formula for cos 2A. We want the result in sine, so we will prefer the formula of cos 2A in sine, that is 1 minus 2 sine square A. Do the multiply. All the results came in sine except this. You know how to convert cos square A into sine. In place of cos square A, we can write 1 minus sine square A. Then do the multiplication again. 2 sine A minus 2 sine cube A plus sine A minus 2 sine cube A, that is 3 sine A minus 4 sine cube A, and its submultiple formula will be sine A 3 sine A by 3 minus 4 sine cube A by 3. From this formula also, simplifying this, changing the side of this 4 sine cube A formula is 3 sine A minus sine cube A. That will be some multiple for this 4 sine cube A by 3 equal 3 sine A by 3 minus sine A. That's the first formula we have in 3A, sine 3A. And exactly the same process we will do for the cos 3A. We have cos 3A formula. Cos 3A formula is 4 cos cube A minus 3 cos A. Do the same process what we have applied for sine 3A. In place of 3A it is 2A plus A. Cos of 2A into cos A minus sine of 2A into sine A. We want the result in focus, so for cos 2A we will write the formula 2 cos A square A minus 1. And for sine 2A we will write 2 sine A cos A into sine A. It came 2 cos cube A minus cos A minus 2 sine A square A cos A. 2 cos cube A minus cos A minus 2 sine square A formula is 1 minus cos A square A. Do the simplification. Here if we do the multiply, it came minus 2 cos A plus 3 cos A square A. 4, it came 2 cos A square A. Sorry, 2 cos cube A. 4 cos cube A minus 3 cos A. That's the proof. And its submultiple formula will be cos A equal 4 cos cube A by 3 minus 3 cos A by 3. When we do the simplify, this 4 cos cube A, changing the side of this, it will be 3 cos A plus cos 3. Here, in sum multiple, we have 4 cos cube A by 3 equal 3 cos A by 3 plus cos A. Then we have the formula of tan 3. We have the formula of tan 3. Tan 3 formula is 3 tan A minus tan cube A by 1 minus 3 tan square A. For proof, same process we have to do. Tan of 2A plus A, tan 2A plus tan A by 1 minus tan 2A into tan A. Now we have the formula tan of 2A 2 tan A by 1 minus tan A square A. Again, into denominator 2 tan A by 1 minus tan A square A into tan A. Take the LCM. 2 tan A plus tan A into 1 minus tan square A. Again, take the LCM 1 minus tan square A. This whole is multiplied with 1 and it is 2 tan square A. These two cancelled. It came 2 tan A plus tan A minus tan cube A by 1 minus 3 tan square A. That is 3 tan A minus tan cube A by 1 minus 3 tan square A. That's the proof completed. And in sum multiple, we have the formula tan A equal 3 tan A by 3 minus tan cube A by 3 by 1 minus 3 tan square A by 3. And same way, we have the last formula for this exercise, that is the formula of cot 3a, that is cot cube a minus 3 cot a square a by 3 cot a, 3 cot a minus 3 cot a by 3 cot a square a minus 1. That's the final formula we have. We can prove this exactly the same process, but we have proved the tan 3a cot of 2a plus a. Now we can write cot a into cot b minus 1 by cot a b plus cot a. Use the formula of cot 2a, cot a square a minus 1 by 2 cot a into cot a minus 1 by cot a square a minus 1 by cot a. That's cot a plus cot a square a minus 1 by 2 cot a. We have written the formula of cot 2a here. Then do the LCM, do the simplification. 2 cot a is LCM. Here it came cot cube a minus cot a minus 2 cot a. Again here is 2 cot a common. 2 cot square a plus cot a square a minus 1. These two cancelled. Cot cube a minus 3 cot a by 3 cot a square a minus 1. That's the proof we have completed. And its sum multiple formula will be 16 cot 3a. Now cot a, that is cot cube a by 3 minus 3 cot a by 3, 3 cot square a by 3 minus 1. We have completed all the formula of this exercise now. These are the ways by which we can prove this formula. Now come to the exercise. Which type of question is asked in this exercise? If we take short questions, question like this is asked frequently in SE. If sine theta equal 3 by 5, then find the value of cos 2 theta. Then we have to solve. Here we have sine theta value is 3 by 5. We have to find cos 2 theta. We have learned main formula of cos 2 theta. Total 5. So which formula we want? Here we have the value of sine. So we will prefer the formula 1 minus 2 sine square theta. That is, value is 3 by 5 whole square. It came 9 by 25. 25 minus 18 by 25, that is 7 by 25. That will be our answer. Then you can do question like that. If 4 by 5, then find the value of cos 2 theta. If sine theta equal 1 by 3, then find the value of cos 2 theta. If tan theta equal 3 by 4, then find the value of tan 2 theta. If cot theta equal 4 by 5, then find the value of cot theta. That's one of the model we have.